Okay, we're going to solve a quadratic equation by factoring. Today's date is 3/24. I'm going to show these notes up here, and I'm going to have the sub pause occasionally so you can fill in your notes. There are 5 ways to solve a quadratic equation. Solve means to find its x-intercepts, its solutions, its roots, or its zeros. Number 1 is graphing, which is not always the most accurate way to solve, as we've learned. Number 2 is factoring. We use the zero product property to find the roots, but not all quadratic equations can be factored, as we've learned. Number 3, we will be using the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This always works, and you will memorize this formula right here. And you'll be amazed at how quickly that will happen. The 4th way to solve a quadratic is to complete the square. And completing the square always works. And what we're doing basically is forcing the quadratic equation to become a perfect square trinomial. And the last way we will use is called finding square roots. And we use that when the b value in the quadratic equation equals 0. For example, this quadratic equation has an a value and a c value, but not a b value. So this is when we might use finding square roots. I'm not going to expect you to understand all this today. I just want to give you an overview. There are 5 ways you're going to solve a quadratic equation, and today we're going to focus on factoring. We've already done graphing. Today we're going to focus on factoring. And again, your sub can pause to give everybody a chance to make sure their notes are complete and accurate before we move on. Okay. We have learned to solve a quadratic function by graphing. Now we will learn how to solve by factoring. That shouldn't be bad since we already know how to factor. Step 1, GCF. You factor out a negative if the leading coefficient is negative, by the way. Number 2, special cases. If it's a perfect square trinomial, it's factored using a binomial squared. If it's the difference of 2 squares, it's factored using sum and difference. Number 3, if the leading coefficient is not equal to 1, we use extra X-man. Number 4, if the leading coefficient is equal to 1, we use plain old X-man. And number 5, not all quadratics can be factored. We've learned all these things. Aren't we smart? Make sure you got that all filled out. Okay, here are some examples. This is a quadratic equation in standard form. Oopsie. ax squared plus bx plus c equals y. Now when we're ready to factor it and solve it, we're going to make y equal to 0 because we're looking for our x-intercepts. And if you think about it, if we're looking for x-intercepts, those are points that are on the x-axis. Every time I have a point on the x-axis, it doesn't matter where it is, y is going to be equal to 0 at that point. That means the y value isn't going to be up here, and it's not going to be down here. Every time we have an x-intercept, the y value is going to be 0. So it makes sense in our equation to make y equal 0, and then we're looking for the values of x that make y equal to 0. Now, once it's in standard form and y is equal to 0, we're going to factor it. We can do that. Go through your menu, go through your steps. This next step is set each factor equal to 0. We talked about that before. We're using the zero product property here. If x plus 7 were to equal 0, then this whole equation would be equal to 0. It didn't matter what this is. So we're going to make x plus 7 equal to 0. If x plus 3 equals 0, then this whole thing is going to be 0, because 0 times this factor will equal 0. Anything times 0 is 0. That's the zero product property. So we set each factor containing a variable equal to 0, and then we solve for x by isolating it. So in this case, we had to get rid of the positive 7 by combining it with negative 7. You do that on both sides to maintain your equation, and x ends up being negative 7. Here, we add 3 to both sides to cancel these out, and both sides to maintain our balance, and x equals 3. Apparently, those are our two x-intercepts. If I graph this function right here, its x-intercepts, or its roots, will be negative 7, comma 0, 0 is your y term, and 3, comma 0. Notice that y is always 0 when we want to find x-intercepts. And again, you can pause, make sure that all gets filled out. If I substitute these values back into my original equation, they should make it true. Here's my original equation from up above. X squared plus 4x minus 21. And if I plug in negative 7 for x, that will in fact, when you simplify this, make y equal to 0. So this is in fact an x-intercept. Negative 7 quantity squared plus 4 times negative 7 minus 21 equals 0. My y is equal to 0. I'm looking for an x-intercept. If I square all of negative 7, I get positive 49. Positive 4 times negative 7 is negative 28. And bring down your negative 21. If you combine your, here's my positives. If you combine all your negatives, you get 49 negatives. Those cancel out. When x is negative 7, y is 0. That's an x-intercept. And if we do the same thing with the value x equals 3, 3 squared plus 4 times 3 minus 21 equals 0. 3 squared is 9. 4 times 3 is 21. Minus 20, I'm sorry, 4 times 3 is 12. Bring down your negative 21 equals 0. Combine your positives. 21 minus 21 equals 0. When x is 3, y is 0. True. This 3 comma 0 is an x-intercept. We found our two x-intercepts and we just verified both of them. Both points make the equation true and both are on the x-axis. Okay, yeah. Example number 2. Y equals x squared minus 5x. Is this in standard form? Y equals ax squared plus bx plus c. C must be 0. There's no c term. Okay, it's in standard form. Now we want to find x-intercepts, so we're going to make y equal to 0. And then we're going to factor. Well, when I factor this, the first thing I'm going to look for is a GCF, which happens to be x. So I have 0 equals x times the quantity x minus 5. There's my x squared, and there's my negative 5x, and that equals 0. Now I'm going to use my zero product property by making every factor containing a variable equal to 0. So here's one factor. I'm going to make x equals 0, and here's my other factor. I'm going to make x minus 5 equal to 0. X minus 5 equals 0. There's that factor equal to 0, and x equals 0. I'm going to solve both of those by isolating my variable, and here I find that x